Trough. The amount of glacial erosion that takes place will vary in different valleys in a mountainous area. Prior to glaciation, the mouths of tributary streams join the main valley, or trunk valley, at the elevation of the stream in that valley. During glaciation, the amount of ice flowing through the main valley can be much greater than the amount advancing down each tributary. Consequently, the valley containing the main glacier, or trunk glacier, is eroded deeper than the smaller valleys that feed it. Thus, after the ice has receded, the valleys of tributary glaciers are left standing above the main glacial trough and are termed hanging valleys, see figure 18.18c. Rivers flowing through hanging valleys can produce spectacular waterfalls, such as those in Yosemite National Park, California. As hikers walk up a glacial trough, they may pass a series of bedrock depressions on the valley floor, probably created by plucking and then scouring by the abrasive force of the ice. If these depressions are filled with water, they are called paternoster lakes, see figure 18.18c. The Latin name means Our Father and is a reference to a string of rosary beads. Cirques. At the head of a glacial valley is a characteristic and often imposing feature associated with an alpine glacier, called a cirque. As the photo in figure 18.18 illustrates, these bowl-shaped depressions have precipitous walls on three sides but are open on the down valley side. The cirque is the focal point of the glacier's growth because it is the area of snow accumulation and ice formation. Cirques begin as irregularities in the mountainside that are subsequently enlarged by frost wedging and plucking along the sides and bottom of the glacier. The glacier in turn acts as a conveyor belt that carries away the debris. After the glacier has melted away, the cirque basin is sometimes occupied by a small lake called a tarn, see figure 18.18c. Sometimes, when two glaciers exist on opposite sides of a divide, each flowing away from the other, the dividing ridge between their cirques is largely eliminated as plucking and frost action enlarge each one. When this occurs, the two glacial troughs come to intersect, creating a gap or pass from one valley into the other. Such a feature is termed a COL. Some important and well-known mountain passes that are cols include St. Gotthard Pass in the Swiss Alps, Tioga Pass in California Sierra Nevada, and Berthoud Pass in the Colorado Rockies. Eretz and Horns. The Alps, Northern Rockies, and many other mountain landscapes sculpted by valley glaciers reveal more than glacial troughs and cirques. In addition, sinuous, sharp-edged ridges called arêtes, French for knife edge, and sharp, pyramid-like peaks termed horns project above the surroundings, see figure 18.18c. Both features can originate from the same basic process, the enlargement of cirques produced by plucking and frost action. Several cirques around a single high mountain create the spires of rock called horns. As the cirques enlarge and converge, an isolated horn is produced. A famous example is the Matterhorn in the Swiss Alps, figure 18.20. Figure 18.20 The Matterhorn. Horns are sharp, pyramid-like peaks that were shaped by alpine glaciers. The Matterhorn, in the Swiss Alps, is a famous example. Photo by Andy Sellinger/Age Photo Stock. Arêtes can form in a similar manner, except that the cirques are not clustered around a point but rather exist on opposite sides of a divide. As the cirques grow, the divide separating them is reduced to a very narrow, knife-like partition. An arête can also be created in another way. When two glaciers occupy parallel valleys, an arête can form when the land separating the moving tongues of ice is progressively narrowed as the glaciers scour and widen their valleys. Rocha Woodena. In many glaciated landscapes, but most frequently where continental ice sheets have modified the terrain, the ice carves small streamlined hills from protruding bedrock knobs. Such an asymmetrical knob of bedrock is called a Rocha Woodena, French for sheeprock. These features are formed when glacial abrasion smooths the gentle slope facing the oncoming ice sheet and plucking steepens the opposite side as the ice rides over the knob, figure 18.21. Rocks moutonnées indicate the direction of glacial flow because the gentler slope is generally on the side from which the ice advanced. Figure 18.21 Rocha Woodena. This classic example is in Yosemite National Park, California. The gentle slope was abrade, and the steep slope was plucked. The glacier moved from right to left. Photo by E.J. Tarbuck. Fjords. Sometimes spectacular steep-sided inlets of the sea called fjords are present at high latitudes where mountains are adjacent to the ocean, figure 18.22. They are drowned glacial troughs that became submerged as the ice left the valleys and sea level rose following the ice age. The depths of fjords may exceed 1,000 meters, 3,300 feet. However, the great depths of these flooded troughs are only partly explained by the post-ice age rise in sea level. Unlike the situation governing the downward erosional work of rivers, sea level does not act as base level for glaciers. As a consequence, glaciers are capable of eroding their beds far below the surface of the sea. For example, a 300-meter, 1,000-foot, thick glacier can carve its valley floor more than 250 meters, 820 feet, below sea level before downward erosion ceases and the ice begins to float. Norway, British Columbia, Greenland, New Zealand, Chile, and Alaska all have coastlines characterized by fjords. Figure 18.22 Fjords. The coast of Norway is known for its many fjords. Frequently these ice-sculpted inlets of the sea are hundreds of meters deep. Satellite images courtesy of NASA, photo by Inger Yoshio Tommy I/Superstock. 18.